Hi, everyone. I'm Mike Yaton. I'm your host from TechSoup. I think we'll just wait a minute or so and give people a chance to join, and then we'll get started. In the meantime, if you want to share in the chat where you're calling in from, maybe what nonprofit you work at, that would be great to hear who all is here. We're really looking forward to sharing with you today about data commons, and we're really thankful for your interest. So I think I will go ahead and get started. And again, I want to thank you all for attending today. I'm Mike Yaton. I'm from TechSoup, and my colleagues and I will be telling you about data commons today, and I hope you'll find it engaging and interesting. I also want to extend a special thanks to google.org for sponsoring this event and our other work to support the sector. Now, first, a little Zoom housekeeping. We will monitor both QA and chat, but in the interest of time, we will not be taking live questions. However, at the end of our presentation section, if there are additional questions, we'll respond to them on chat or through the session. Closed captioning is available. You turn that on with the CC button located in your Zoom menu. The session will be recorded and the link shared via email with all registrants. So first, a bit about TechSoup if we are new to you. TechSoup acts as a bridge for nonprofits to access technology products, services, and support. We serve approximately 300,000 organizations a year through our programs and have served more than 1 million to date. And one of our offerings is education, like today's webinar. Now, I'm delighted to introduce your presenters. First, as I said, I'm Mike. I'm the Data Commons Program Manager at TechSoup, and I've previously held technical leadership roles in the private sector, foundations, and nonprofits. But I'm more happy to introduce my outstanding colleagues. First, Hassan is a front-end engineer and web designer, but I consider him a data storyteller. He's very experienced, and last year received his MFA in technology and design from Parsons in New York City. He's also a DJ and a musician, and links to his work are in his bio. Mansi is an experienced technology leader in data infrastructure and analytics, and she's formerly the chief technologist at VMware. She currently serves as head of software at a green tech startup, and I'm happy to say, as a technical advisor for this project. She has a passion for green tech and co-hosts a podcast with a colleague. The link to that is in her bio, which I encourage you to check out. And I also want to send out thanks to Andrew, our producer, for working behind the scenes, and Corey, one of our teammates, who will be answering questions and posting links in the chat. So first, let me tell you a bit about how this session will be structured. I'll start by giving you an overview of data commons, what it is and why it matters. I should note here that we frequently refer to this as DC. Then Mansi will explore using DC for data analysis, first with the built-in tools, and then pulling data out of data commons for deeper analysis with other software. Next, Hassan will talk about what makes an effective data story and provide some really compelling and interesting examples. And then we'll close with the next steps you can take. Now, because we have a lot of ground to cover, this will be more of a flyover than detailed instructions. We won't do live demos, but we will share links in the chat so you can explore them for yourself. We'll concentrate on key concepts versus a detailed how-to guide. But at the end, we'll show you how you can sign up for a free hands-on workshop organized by Corey to learn more. The product manager in me has to say one caveat. I don't think we've ever had 200 people hit our site before at the same time. When I asked our lead engineer about capacity, he said, go for it. Then after a pause, he said, it will be a good test. So if it's a little slow, please feel free to try those links after the session, and we might need to bump up our cloud resources a bit. So first, what is data commons? At its heart, data commons is a knowledge graph for public data. If you're not familiar with that term, don't worry. It's similar to a database, but kind of broader and more far-reaching. I'll explain more about what that means in a second. The mission of Data Commons team at Google is to organize all the world's public data and make it universally accessible and useful. Now, that is a really lofty goal, I'm sure you'll agree, but hopefully by the end of the session, you'll see that it's actually possible. And they've delivered this in a very open way. There is no login or subscription required to use it. It's an open source platform that anyone can download and run for themselves. In fact, the examples we'll be sharing today come from our own instance of Data Commons, which we support for civil society. And it's also based on schema.org standards, which let search engines and other applications find and utilize the data. So what kind of data are we talking about? First, it's massive. there are more than 120 sources, 250,000 variables, and more than 250 billion data points. Second, it's authoritative. These sources most of them come from very credible, widely recognized government or large international agency sources, and it's very broad. It includes demographics, health, economy, environment, essentially all aspects of life on Earth. Now to the knowledge graph question. What does it mean to be in a knowledge graph? What it means is that every data point is connected to all other data for the same time and place. So for example, the county I grew up in is Alameda County in California. Now, the place and time are, of course, data dependent. Data may exist at one level or multiple levels: county, state, city, postcode, etc. And time interval can also be different. Data could be daily, weekly, monthly, or annually. But every data for the same time and place is joined and linked to every other data that has it for that same time and place. In addition, there are multiple ways to access this data. The easiest, and that one we'll show you today, is the natural language search. Now, this is not like a large language model that we're used to working with like ChatGPT now. It's just connecting you to the data more easily, and it's not making things up or inventing facts. It also includes built-in explorers, which we'll show you, a data download tool if you want to extract the data and use it with another piece of software, as well as APIs for other popular software. Now, I'm going to quickly show you some of these explorers so you have an idea of what you can do with the tool from that standpoint. I'll start with the Place Explorer. And this is the response I get when I simply ask Data Commons, tell me about Nigeria. And you can see a snippet on the left, but the full output on the right. And this produces a wealth of information about that place. Now, it may not be exactly what you're looking for, but it's often a good place to start and understands what's available for that particular geography. Next is the Map Explorer. And this lets us quickly visualize one data point or variable on a map. In this case, it is the number of aid worker security incidents over the past 10 years. And this data comes to us from Humanitarian Outcomes. I can see based on the color and a hover, if I do it on the site, that South Sudan had the highest total number of aid worker security incidents for the past 10 years. But what if I want to compare two countries over time? I can now go to the Timeline Explorer, which lets me compare the same variable for different geographies over time. I'm sticking with the Humanitarian Outcomes data, but this time looking at aid workers killed in South Sudan and Palestine over the past 10 years. And you can immediately see the impact of the war in Gaza here. Finally, the scatter plot. Scatter plot lets you visualize the relationship between two variables for a given geography. In this case, the y-axis represents the median income of households. The x-axis is another county health ranking measure of premature deaths in a community due to accident, injury, or disease. And every dot on this chart represents a county. Now, unsurprisingly, counties with higher income are likely to live longer, healthier lives, as we know very well. Now, to really appreciate DC and Data Commons, the power of this tool, I want to take you through an inquiry that I might do before and after having access to Data Commons. So let's say I'm sitting on a park bench with a friend reading, and I see a piece in the New York Times that talks about food deserts and their relationship to health factors. And I think, how might I explore that question for our community? Now, I'm going to show you first how I would do that before Data Commons and then with Data Commons. So before Data Commons, I first need to find a source that is a measure of food deserts. So I poke around on the internet and I find several candidates. But I'm just going to choose the county health rankings food environment index because it accounts for both proximity to healthy food and the affordability for that community based on their income. Because of course, it does you no good to have Whole Foods in your neighborhood if that's beyond the means of most of the residents. And then of course, I will then have to navigate to their website, find the download page, and then download that index for US counties. Now, as I said, I'm interested in what happens to the diabetes rate as the food index goes up and down. So I need to find a second data source to represent diabetes. Here are some sources that are commonly referenced. In this case, I will choose the CDC for the US Center for Disease Control because it's an authoritative source. As before, I must find and download that data set. Okay, so now I've got two tables together. What steps do I need to actually see these together? Well, there's several steps. And sometimes it could be easy, sometimes it could be hard, but it's never usually simple. So let's talk about what's here. First, I see that in these two data sets, I have some unneeded fields. So I'm going to delete those. That's pretty easy. Just remove those columns. But second, a little more subtle, I notice that only one of these data sets has what's called a FIPS code. And a FIPS code, if you don't know, is a unique identifier for counties in the United States. Why is that important? There are 30 Washington counties in the United States. So if I don't have a FIPS code, then I probably need to merge state and county in these data sets so I can actually join them together. Next, county names are subtly different. Now, you and I look at this and say Amador, Amador County are the same, but the computer, of course, will treat these as different. So once again, I need to take another cleanup step to either add or remove county so that these columns can be joined. And then once that data is clean, I now need the skills to merge and analyze the data. So I'm going to be using Excel, Tableau, Python, something like that to actually go ahead and merge these two data sets together. So I can actually then make that scatter plot that like I showed you before. So I'm just curious if any of you, I'm sure some of you on this call have done this before yourselves. So if you have done this before and you found it challenging or tedious, I'd invite you to share a comment in the chat. So let's now contrast this with how I would do this in Data Commons. In Data Commons, it's often as simple as just asking a question. So in this case, I'm asking Data Commons to tell me food environment index versus diabetes for US counties. And the versus in this case tells Data Commons that I'm looking for two variables on a scatter plot. So here's what it produces, a scatter plot. So on this chart, the y-axis represents the food environment index. The x-axis represents the percentage of diabetes in that place. And again, as before, each dot represents a county in the US. And I can see a definite relationship between food deserts and diabetes. But of course, I started this with the question, how do I see this for my own community, Alameda County? How do I narrow this down? Once again, Data Commons makes this extremely easy. I can simply edit my query and replace US with California, and I'll get the same exact scatter plot, but only for counties in California. And I can see by hovering over it that my county, Alameda County, is relatively well positioned. It has both a high food index, relatively high food index, and a relatively low rate of diabetes. It's in the upper left quadrant, which is where you want to be. I also notice in this that no counties have high food index and high diabetes rate, showing again a strong relationship. Straight from here in Data Commons, I can download this chart directly and include it in a presentation or a document I'm writing or a web post, or I can export the data and then use it in another tool, which is what Mansi will show you in a little bit. But remember I said at the beginning how in the previous method, if I want another variable, I've got to go find that one, I've got to download it, join it, etc. What about Data Commons? It's very easy, just like I did for the state, to replace that one of those variables with something else and see what that says. So I'm going to show you first, how does the food environment index relate to other variables besides diabetes? Let's look at heart disease. Here we see a very similar pattern and a very clear relationship and slope. How about median income? And right away, we can see there are no well-fed poor communities, unsurprisingly. How about vulnerability to disasters, be that natural or pandemics, etc.? And we see again, communities that are more vulnerable to natural or other disasters are less served by healthy food offerings. And finally, I want to show you one that's a little different. Those all showed a clear pattern. Now I'm going to look at the relationship between the food environment index and forecast temperature change. Now, I don't see a clear slope like I did with the others, but what I can do here is maybe take a different approach. Here's my thesis. If you have to travel to get healthy food and it's getting hotter, that will become more difficult. So rather than looking at a trend here, I might dig in and say, which counties have the lowest food index today and are likely to be hit the hardest by climate change? If I'm a food bank or I'm thinking of strategically, that may influence where I choose to put some of these locations. Now, I think this is an amazing tool. And all of us who work on this have moments of experiencing really magical. In fact, even our producer was saying he was feeling that this morning. But of course, we at TechSoup are here to tell you the real deal. And this tool, like any other, has its limitations. So let me tell you what a couple of those are. First, the fact that you have access to this data, all this data, does not mean you understand it. And for example, what I show here is 4 different climate forecast models that are included in DC. Now, DC will not tell you which one of these to use. So to make a decision about that, you have to do your own research or consult with someone to help you make a choice. Second, we could see the relationships in the data, but DC itself does not include built-in statistical tools for doing things like calculating correlation or significance. And finally, there are limited customization options for the visuals. So I really love this chart, by the way, which I prepared for this, which shows the unemployment rate in Alameda County versus Merced County in California. And what you can really see here so vividly is the effect of an agriculture county versus an urban one, meaning the seasonality of employment. But just to take this example, this is a great chart, but if I wanted, say, within Data Commons to change the timeline, that's not available to me. So there are these limitations, but I will say again and again, these are very effective tools to use as a starting point for your analysis. Frequently, you could just reuse these assets so easily. And most importantly, you could easily export the data and use this with other tools if your needs go beyond the base Data Commons, as Mansi and Hassan will show you next. So I will pass it to Mansi.
Thank you, Mike. So I want to share my screen for a second. So as Mike showed so eloquently, that the tool is magic. The tool, actually, the data is magic. And we are all living in this magical world where we have access to lots and lots of data. But with that access to lots of data, it oftentimes feels like finding the hypothesis or the analysis that we are looking for feels like a needle in the haystack. So with that, I want to sort of take a high-level approach to how do we go from lots of data to insight. And to me, there are 3 aspects of going from data to insight. First, we need to organize the data we have into buckets of useful, unuseful, and related information. Then you want to try and analyze it to also potentially either find a correlation between the data that you have, to find a hypothesis that you're trying to prove. And then in some cases, you want to do some prediction to come up with a story that says that with what is happening today, this is a potential outcome for the future. And these to me are sort of 3 aspects of going from data to insight. Now, how does Data Commons help us with this? Data Commons already actually, like Mike has shown us, does help with a lot of organization. And I'll also show a lot more examples on that. So the natural language search, the inbuilt capabilities to correlate to parameters, these things are already helping with some level of organization. And also to some extent, some level of analysis, at least visual analysis, if not actual statistical analysis. And then the next steps, I want to show how easy it is because the data is already joined on place and time in our Data Commons, how easy it is to download this data into any tool of choice. My tool of choice is Python, and to download it and actually analyze it to do our next level of insight. So with that, let me first start out by showing some organizational capabilities of Data Commons. Here I'm asking Data Commons a very simple question. Tell me what is the immunization status in a country, India, a country I grew up in. And for a data person coming to this question, I actually didn't know how many different dimensions there are to this question. It's not just about what are the different vaccines and their individual immunization rate, but then there is also how is it looking between female population and male population, which actually is an important question in India. And how is it looking between rural population and urban population? And the point I'm trying to make is I did not ask any of this to Data Commons. It literally just created a page for me with all of this and more information put together and for me to consume it. Now, when we say AI, I want to debunk the word AI a little bit for where I come from. This is, if you can if you will, you can think this is AI, but this is basically just the machine trying to understand what it is that you are trying to do. What is your intent here? And trying to put together information that would be useful for you. There is no human being in the back end saying that these all parameters are useful. It is the machine trying to identify which parameters or which features of data that I have are useful to the question that is being asked. And hence we can call this AI machine learning, but this basically is an extremely powerful capability that you can use for data commons to try and sort of start your initial foray into analysis. Now, going from a global question like immunization in India, I wanted to take a very, very micro question, like what is the commute times in San Francisco, a place where I live? And here it shows that a lot of people are wasting a lot of time commuting in San Francisco, almost half an hour every day. But it didn't stop there. It went ahead and told me how is the population distributed across different commute times? What are the different modes of commute that people are using? And I don't have a chart here showing that, but if I had gone into any one of these, I could have looked at different views of the same information. For example, I can look at a time scale view of or a timeline view and see how has the mode of transportation of folks changed over the last several years. And it will quote where the data comes from, but it will also show me that since 2020, we're seeing more people are working from home and not commuting, and the use of public transit has dropped down. So this is the kind of visual and human analysis that the tool is already helping us with. From here, I want to start talking a little bit more detail about an example where I want to do a deeper analysis. So I started out by asking data commons, tell me everything you know about Santa Clara County. And I'm going to do a bunch of county analysis, but I just wanted to see what does data commons know about a specific county. And it is very smartly looking at all the information it has and categorizing it into different buckets. So it's showing me what does the economics of the county look like? How does it compare to other counties around? What does health look like in the county? And if you can see, there is an impact of COVID that we can clearly see. What is the drug usage around the county? How does it compare to other counties? What is the education? What is the demographics in the county? What is the housing situation? What is the environmental situation? What does the equity between races and genders look like? So this, I mean, just if you spend half an hour just staring at this page, that itself will blow your mind, according to me. It did blow my mind. But moving on from the fact that there is all of this information about the county, I decided to sort of focus on a specific question. I said, okay, there is all this very interesting information about counties available in data commons. I want to know, how does education impact people's quality of life? And obviously, we have some notions of what that might do. What does education do to quality of life? But I wanted to take a very unbiased approach to this. And as a first step, now what I need to do to sort of carry forward my analysis is I want to first get all the relevant information from data commons. And in this case, I'm going to download it and do a little bit deeper analysis of my own. So I'm going to show you how did I get to all the information and then what did I do with it. So here I'm showing you a map explorer tool. And I have asked the data commons to tell me what is the population that has bachelor's or higher degrees in these counties. And if you can see, I can also click per capita, which then gets me data that is comparable from one county to the other and is not dependent on the population density of the county. And then if I just say download, at that point, I can actually get a CSV from data commons that is in a standard format. And it's telling me what is the geo ID, the FIPS ID of this county, what is the name of the county. And these will always be standard, no matter which parameter I'm trying to access. So it is trying to give me something that I can very easily correlate in my choice of tool. So with that, then the next thing I did was, what is the obesity rate in any given county? Then I tried to get what is the mean income of any given county. So I downloaded a bunch of different things like food insecurity, obesity, something completely unrelated. For curiosity, I said, how does temperature change look like based on people's education? Mean income, immigration population, percentage of people who are immigrants in a county. I got all of this data as CSVs from our data commons. You could have also done a simple API call and gotten this information. Now, this I want to emphasize is a small example I am trying to show here for the sake of this webinar. But think about doing this across 100 parameters and trying to find insane correlations and things that you had never imagined are actually correlated through a simple step. And here is the simple step that I had to take to find these correlations. I'm very intentionally showing this little snippet of code because I want to emphasize how small the code was to be able to create this heat map of how education is related to all of these different quality of life measures. And I'm not calling out causation here. I'm just showing what the heat map looks like. So the key point to emphasize is that because the data was already joined by time and place, I had to do very, very little, like 10 lines of code to create a simple data frame with all of my parameters and call a heat map function on it to spit out this image. And as you can see, I was quite surprised that obesity is negatively correlated to education, which now doesn't surprise me. But the first time I saw that was like, oh, okay, I hadn't thought that's true. But these are the kinds of things. And again, please understand, you could do this on hundreds of variables with just this simple code. And that is the power of having pre-joined, pre-curated data at your fingertips. I want to take quickly another example. In this case, I want to do some predictions now. I was thinking, how is the housing crisis looking? Is it going to get better? Is it going to get worse? What are the contributing factors to this? So I'm not a researcher on the subject. I am a data person. So I just chose a few things that made sense to me and picked up what's the population growth? Are people living in rural areas? This is the rural area line. This is the urban area line. Are they living alone? Are they living with other people? So that tells you how many households you need, and what is the rate of households that we are building. This screen that I'm showing, you can very easily get from data commons. This is the part that the data commons is organizing information for me. And we can get these correlated timelines from data commons. Now, I downloaded that data again and did a very simple polynomial modeling on it. Of course, there can be very many different kinds of modelings that we can do on this, and there can be a whole research study on that. But a very simple 20-minute modeling showed me that if everything continues the way it is, what's going to happen is more people are going to stop living in rural areas. More people will start living in urban areas. People will start living alone more and more. And hence, if we don't build more housing, the number of households we are going to need is going to exceed somewhere in 2040 from the number of houses that we have in America. And this, my friends, was again a 20-minute exercise for me, but that is the power of the tool underneath. Now, I want to emphasize one fact, though, that this kind of analysis, maybe some of you who are very statistically inclined might have quickly caught on to my heat maps and my timeline analysis and predictions. But most stakeholders to whom we are trying to sort of build these narratives for, the reasons we are building these narratives for, those need to have stronger stories built around them, stories that are visually very intuitive, that are telling a complete, comprehensive outcome. And for that, I'm going to hand off to my colleague, Hassan, who's an expert storyteller and is going to tell us a bunch of things about it.
Hey, you all. Excited to speak on this topic. Let me just share my screen. Okay, now that we have analyzed our data, in this section, we're going to talk about how can we use some design principles to build an effective visual story out of our data, and how data commons can aid us in this entire process. So I'll start with how you can use data commons in your storytelling and communication areas. One important thing to note is that all visualizations on data commons, on its search pages, on its explorer pages are downloadable. And the fun thing about them is they're downloadable as SVGs. So if you're a graphic designer, you can actually change the color palettes and edit them the way you want to. What that then helps is you get pre-made visualizations, which you can use in your reports. You can use them to build infographics for your campaigns. You can also use them inside your articles and research for your organization. Now we're going to talk about how narrative stories can be built. These will go into a more custom storytelling territory, and we'll talk about some design principles that we can leverage to build a good visual story. When it comes to visual storytelling, it's important to reflect on why we're telling the story in the first place. And the way we do that is we go through an exercise which I refer to as the 3 Ws. We want to try and figure out why we're building this project, what are we hoping to accomplish from it, and who are we building it for. And thinking about your audience is very, very, very important, because the granularity, the detail, the interactivity that we go into the project is directly a product of who we are building it for what purpose are we building this. So as an example, we'll share this project in the chat. TechSoup built a food, farming, and climate change story using data commons, and the story went live roughly 6 to 8 months ago, I believe. And we're gonna think about what the 3 Ws for a story like this could potentially be, right? So why we were trying to demonstrate the power and the data contained inside data commons. And then what we were building was a project that would explore the impact of climate change on farming, see which areas of higher food security, food insecurity, and how both of these phenomena would relate to each other. While doing so, we were also hoping to share TechSoup's partner food organizations working in this area. We built this for a UNGA audience because it was supposed to be presented there, but we also built it for community stakeholders and TechSoup's network organizations and audience. So why do we build stories, right? We can build them for awareness campaigns. We might be building them for donation programs where our primary objective is to raise money for a particular task. We might be building investigative stories. We see this a lot in journalism. We might be doing them for community outreach. We might be doing them for marketing and branding, right? What else can you think about in terms of goals for storytelling? Drop your ideas in the chat. We'd love to hear from you. Why are goals important? There are several mediums for storytelling, right? Web, video, print, multimedia, and our objectives, the people we want to reach, the kind of stories we want to tell, are tightly coupled with the kind of medium we choose. And this is why it's very important to think why we're telling the story in the first place. That will directly seep into whether we are building an infographic. Are we building an interactive story? Are we building a data visualization? How granular that visualization is, etc., etc., etc. So what makes a good story? I'm going to go over some design principles. We'll explore examples of each design principle to try and get some context around why these work. So the first is having contrast and white space creates focus. So one of the most important things in a design is actually empty space. Emptiness creates focus and brings the areas in our design that we want to bring in front basically into a user's attention. So when we look at this data visualization that we built for in a project called Hunger and Gender in Mexico, built in partner with one of TechSoup's partners, organization SEMEFI, we see that we have this sort of border around our text that's helping bring that into focus, but most of the color and contrast is going into data visualization. So we've used leverage, contrast, and emptiness to try and tell the user, these are the two areas you look at. And you've got other content across the page. We've got scales, we've got sources that we are, for where the data came from, and data commons branding, but they're secondary in this space. So contrast and white space is eventually bringing these two elements in focus. What makes a good story? Less is more. Whenever we're communicating in narrative, we want to do it in steps. Bite-sized information is easily digestible because it leads the user into the kind of narrative we want to tell them. If we tell people too much, we run into the risk of overwhelming them and they perhaps might lose interest. So this visual is from our food farming and climate change story, and it's looking at food insecurity inside the US. And I'm going to show the two stages that this visual takes. So the first stage is we're looking at food insecurity in the US. The visual just shows percentage of food insecure people in each county of the United States. But then we filter it down to which counties have food insecurity higher than the national average to try and show which communities are perhaps suffering higher food insecurity across the US. If we did this from the get-go, we might run into this risk of people trying to figure out what all these gray counties are and why are they gray in the first place. Visual intuition. Colors have meanings. We have implicit meanings that we associate to colors. Here's an example also from our food insecurity story. So I'll start with an intuition, right? The left map shows peak temperatures that the US is forecasted to have, each US county. The right visual shows farming cover in each county in the US. And if we look at it, I think the intuitive response is red denotes hotter temperatures, green denotes more farms. But why is that? It is because there is a familiarity, an intuitive response, a meaning that we've associated to colors in our space, right? So green is used for nature throughout. Green is even used in policies. So the Green New Deal, we automatically know this deal has to do something with climate. Again, so that sort of, and in the general branding that we see around forestation, around climate, we see the color green used a lot. So we know that we can leverage that to give a person sort of this intuitive response on our visual. The same is with temperature. We denote red to hotter temperatures. We denote blue to colder temperatures. It is very important to try and evaluate how our information would be perceived at a glance. And this directly ties into the medium we choose for our storytelling. So if we're using Instagram, if we're using sort of mediums where we know the kind of engagement we're going to get is within a couple of seconds, we have to be very focused on how people might perceive our information. I'm going to go through an example for how people can misperceive correct data in a visual. So here's a map of general election results in Pakistan from 2018. We're going to explore how a person could potentially misperceive the results there. So let's filter it down to seats won by BAP, which is a political party. And then let's filter it down to seats won by MMA. Now, the image automatically shows us almost approximately 1/3 of Pakistan's area. So one would assume that both of these parties, if not have won 1/3 of the vote, they've won something closer to that, except that this entire geographical area represents 20 out of approximately 345 seats in the parliament, which is 5% of the entire electorate. How do we fix this? So here's another map on the right, which is showing the same data just in a different way. Now it's showing a bubble, which denotes a seat won by a party in a particular geographical region. but it actually captures two things. One, it's capturing the spread of votes throughout, so it's easier and more intuitive to see that the purple party, denoted by red in the map on my left hand, it's easier to see that the purple won a majority, but it's also easier to see that how the seats are spread out, how the vote actually. So when you see it on a glance, when you see it in a second, 2 seconds, when you see this image, you are not likely to visually misperceive results. There is some risk of this in US elections as well. So if we use that as an example, District of Columbia is very small. New Jersey as a state is actually very small compared to, let's say, some of the bigger states like Wyoming in terms of area, but they might not have the same electoral college votes. So how do we build sort of alternative visuals that can capture this information as well? It is important to use standardized data, rates, percentages for consistent comparison. So this map, you won't find it in any of the stories, but this map is actually showing total farm area across US counties. If I were to put this map side by side with total area in US counties, we'd see a very similar map, because even if we look at this, we see the greenest county is the biggest county as well. So we're seeing that bigger area has bigger farm area. If we divide farming area by total area of a county to get percentage of area covered by farms, we get this map, which is completely different in terms of how it's spread out. But it's actually giving us a sense of counties within the United States that are more economically dependent on farming as a means of generating output, right? So we see same statistic rendered differently. And we see how powerful using a rate, standardizing information. We also call this normalizing information in statistics, how important that is and what a difference it can make. So it's always better to use percentages than absolute numbers. If you're building visuals on populations, try to get percentage of populations, try to get rates of immunization rather than absolute numbers of people suffering immunization, because that's directly dependent on what your total population is. So it might not tell the entire story and can be misperceived. Visualizations show trends. They're really good for trend analysis. They may not imply causation. Even if you get 10 visualizations that are showing the same trend, that does not necessarily mean that there's statistical causation. So there's some sort of, dance between data, visual design, all of it that happens at the same time. So if your goal is to see if there is statistical causation there, you have to do some more data analysis to reach that conclusion. Now, for custom storytelling, Data Commons actually has an API. So all of the ways of fetching data that we showed you before were through the Data Commons GUI, the graphical interface, but it has an API which you can use to fetch in all of the data points from Data Commons. We saw one example of it prior when Mansi showed us her Python code, right? And what that means is we can use the API to build our own interactive stories using any platform. I've listed a bunch here: D3, JavaScript, Mapbox, Flourish. We can talk about other tools. If you have any other tools in mind, please feel free to drop them in the chat. I'm guessing we'll hear about Tableau and Power BI quite a bit. Now, wrapping up, I'm going to pass this back to my colleague, Mike.
Thanks, Hassan. Well, that was a quick tour, and we hope it was interesting and stimulated some thinking about where you might want to do with Data Commons. I just wanted to kind of explain sort of what we can do for you from here, where you might want to go. So again, I mentioned at the top, but this webinar and a lot of our outreach work to the sector is sponsored by google.org, for which we're really appreciative. And that will include some upcoming workshops, which will be more of a hands-on using Data Commons approach, which Corey is on our team is organizing. And we can offer that for free. And the other thing we can help with, if you are interested, is especially if you are currently sharing your data, maybe on your own website or through other channels, and you'd like to see how that works with the knowledge graph, we can help you to share that data. One thing I did not talk about, because again, we didn't want to overload this intro session, is the difference between what the main data commons is that Google hosts and the one that we host. And just to say, we have a custom one that we've launched, which includes all the data that Google has, but also data specific to the nonprofit sector and is specifically for non-commercial use. So let me just leave it this way. If you're interested in contributing your data, oops, Corey, I see maybe our workshop link had a oh, he's gone that. Anyway, so if you're interested in contributing your own data or exploring that idea, we'd be happy to talk to you about that. And again, no charge for that service. In addition, we do offer extended or charged for services for advanced stuff, including advanced data analysis, custom visualist storytelling, like the examples Hassan showed, and if it's relevant for you, setting up your own DC instance, which is like us, you could do the same that we've done as well. And again, that probably requires a little more of a one-on-one conversation to figure out what options are right for you in these areas. But if you're interested in that, feel free to email us, datacommons@techsoup.org, and we're happy to set up a call. And again, next steps for you, please. Go ahead and fill out that feedback form, if you wouldn't mind, so we know how well this worked for you and what else you might want to see in the future. As soon as this form is fixed, you can click on that link and should be able to access that feedback form. If for some reason that's not there, just send an email with your interest to this email address, and Corey says, try it again. And really, most importantly, just please feel free to give it a try for yourself and explore. And again, our data commons is at datacommons.techsoup.org. You can also explore the main DC. But again, we have all their data as well as our own unique contributions from nonprofits and other organizations. And that is the end of our webinar. So we'll just pause here. We're close to time. We'll just pause here. I see Marie. And can I ask you, I guess we could, Andrew, can we call on Marie? Why don't we do it? We're live here. Let's do it.
Yeah.
All right, let's do it. I don't know how to raise your hand. Can you? Let me see.
I
I
believe
see an indicator, but I don't know how to, sorry, I haven't done this before. Andrew, can you invite her to speak? Andrew says you can go, Marie.
I just want to let you know that was a mistake. I just want to say thank you. That's very interesting presentation.
Great.
So I didn't mean to press on the
Good.
speaker microphone. Sorry.
That interruption is welcome anytime, Marie. Thank you.
Okay, sorry. Bye.
But anyway, if anybody else wants to go on live mic and ask, we're happy. We got 10 more minutes, or we can take them in the chat if you prefer. All right. And then, yes, a request to send out the links to the form.
I'll just there was a question in the chat by Amita. So the custom storytelling stuff that you see is custom development. Those aren't out of the box through DC. What you get is essentially you can use those APIs, and what that helps you is a lot of data processing work that goes before building a custom narrative like this. So a lot of the preparatory work that goes into the project is reduced, but yeah, the food farming story or the Semefi story they're custom development.
Thank you, Hassan.
Yeah, and, just to add to that, this is Mike, just to say, yeah, so I think of these as kind of a spectrum, and that's what we try to convey. You can get the built-in visuals from Data Commons, but they're going to have fairly limited customization. There's also, we in our own work, we'll sometimes build a Power BI dashboard or like an Esri story map or something like that. And those are better. I mean, they're more customizable, shall we say, but they're also not to the level of what Hassan does. And again, it kind of depends, like he said at the beginning, on your audience. We definitely, I've built so many Power BI dashboards, and I always wondered why people didn't use them more until I met Hassan and kind of started to learn that, I really have to think about what expectations I'm putting on my readers. And so that's really the power of what Hassan does, is not just the technology, but really thinking through, as he likes to say, what's the cognitive load you're placing on someone who comes to your site to read this, and really thinking about it that way. So again, we have a few slots available. There's not a big team. There's 5 or 6 of us part-time. but we do have a few slots if we could help you in any of these ways to use it in more for other purposes. But again, happy to help you on our free support for the workshops. And again, if you're interested in contributing data, just reach out to us via email.
Mike, can I ask a question?
Of course.
In regards to either the workshops that were mentioned on this call or perhaps other offerings you might have, would any of them be appropriate for a younger undergrad student, example, someone who doesn't have a lot of professional experience, but just is trying to explore how to use data as part of their storytelling in their future career? Would any of these workshops or anything else outside lend themselves to that type of a demographic?
Well, I hadn't really thought about it at the workshop, to be honest, but I will say we're open to supporting academic uses of data commons. We have a number of data commons contributors now. The World Policy Center from UCLA is contributing some really interesting data, which you can look at on our site regarding to the legal age of marriage for girls around the world and paid parental leave and things like that. In addition, I see Amari, for example, on our chat here is from NYU Cusp School. We're also supporting them with a capstone project for their master's program. Also, there's a datathon coming up at Stanford next weekend for undergrads, where we'll be helping with that event as well. And that's to find kind of creative uses for data commons to interesting problems to address with it. I mean, I think in general, you know, the accessibility for data commons is probably more a function of your comfort with data than it is for, you know, what particular level you're at, right? Like an undergrad who's familiar with data science should be a fine candidate to explore this. And I guess I would just say, send us an email if you have some ideas, and we're happy to talk to you about it. We probably would want to support that as some, you know, like I said, we could support an event or something like that potentially.
Thank you.
All right. Seem to have wound down. Another one?
Yeah. Ed, you can go ahead.
Okay. Well, I hope that was interesting. And again, I encourage you guys to take advantage of some of the follow-up offers if those are of interest to you. You know, I think fundamentally the guys who started this at Google had good intentions because it was it was sponsored by a Google fellow. And I really think that the root of it they felt was like, we just need more truth in the world that is objectively sound. And I think this is an effort to really put that data in as many hands as possible, so all of us make better decisions, and particularly nonprofits think about their strategy better and able to communicate their impact better and all those things. So again, with that, we'll close, and thank you all for your attendance today. Much appreciated.
Thanks all.